Hello students, welcome to competitive exam library. Today we are going to see what is the problems based on the alternators which are given in the previous papers. Okay, so let us take the first problem. First I am going to read the problem. A 3-phase 50 Hz 20 pole salient pole alternator with star connected stator winding has 180 slots on the stator. There are 8 conductors per slot and the coils are full pitched. The flux per pole is actually flux, it is there. Flux per pole is 25 milliwebers assuming sinusoidally distributed flux. Calculate. Okay, first question is speed, generated EMF per phase. Second question is line EMF. So before going to that, okay, so you should know some formulas which are very important. So for solving of the problem, here what is that is Kp. Okay, Kp is known as the pitch factor. Okay, Kp is known as the pitch factor and Kd is known as the distribution factor. So these are the two factors which are there in the windings, but in our syllabus it is not there. So the derivations are not there, but you should know the formula. And one more thing is known as the winding factor. Winding factor is actually the product of Kp and Kd. That is what we are already discussed in the EMF equation of the alternator. So you can see there. So we are multiplied Kp is equals to Kd. So if Kp is equals to 1, if it is a full pitched, okay, Kp, sometimes he will use the word it is the full pitched coils, means that you have to Kp you have to take it as 1, then at the time it will become Kw value will become exactly equals to Kd. So but in the syllabus it is not mentioned that so you have to take the what is the how you are getting the Kp and Kd. So no need to take the derivations. If you see, observe the syllabus, so he is not telling that the derivations are you have to consider. So that's why I am not consider the derivation of this Kp and Kd, but I can give the definitions of Kp and Kd. So Kp is defined as ratio of EMF. Okay, so EMF with short pitch coil. Okay, so what is the meaning of short pitch means? For example, if the coils has to be 1 to 10 you have here arranged, that means first slot you have to place the conductor, actually you have to place in the 10th slot. So we are not doing that, then we are placing that that is in the 9th slot. For example, here 1 and 9, this is called as the short pitch. Okay, this is called as the short pitch coil. Okay, short pitch, why we are doing is because to reduce the harmonics. That is the reason what we are doing here in case of the alternator. EMF with short pitch coil divided by EMF with full pitch coil, that is defined. EMF with full pitch coil. Okay, that is the definition of the Kp. So if you observe, Kp is full pitch, I already told if it is a full pitched value, while for short pitch, okay, so short pitch always the Kp value will becomes less than 1 only. That is about the Kp. Next we will see Kd. Kd is known as the distribution factor. It is also defined as EMF with distribution, EMF with distributed winding to, okay, so EMF with distributed winding to, next EMF with concentrated winding, EMF with concentrated winding. So this is the difference. So distributed winding means actually it is distributed. Concentrated winding means you are going to place in one slot only, like that 2 conductors. In one slot only you are going to place the 2 conductors like this. That is called the concentrated winding. And the Kd value will distributed means it is distributed only one conductor in one slot. That is called as the distributed winding. So Kd value, let us take the, if you take the Kd value, the Kd value is equals to 1 for concentrated winding. Okay, so Kd value is equals to 1 for concentrated. Okay, that is 1 for concentrated winding. So Kd value is less than 1. Okay, Kd value is always less than for distributed winding. So that is the basics you require to solve the problem. That's why I want to give all these basics, very important. Okay, so this is the basics which we are required for the solving of the problem. Okay, because he is in the problem, if you observe, it is given as full pitched. Okay, so if you observe here, it is given as full pitched coil. So what is the meaning of full pitched? All these things you have to know. Full pitched means Kp value will become 1 at the time. Okay, right. Let us move so to the problem. Let us see the solution here, how to solve the problem. Okay, so I think you have to note on all these things, okay, which are very important. So for solving a problem, this much is required. What is required I solved here. Okay, I have written here. Okay, let us take the problem. See this problem, how the problem it is given, a 3-phase. Okay, so let us given, first I am writing the data. So frequency is given as 50 hertz. Okay, this is the frequency is given, and number of poles it is given as 20 poles. Okay, next salient pole alternator with star connected. Okay, star connected, that is also very important. We are already discussed, always the stator is connected with the star connected, and it is having Z is 180 slots. Okay, and on stator there are 8 conductors per each slot. Okay, so there are 8 conductors per each slot. So how much it will become, 18 into 8. Okay, so we'll do later. Next is the flux per pole. The flux per pole it is given as 25 milliwebers, that means 10 to the power of minus 3, that is 0.025 webers we can write. That is the given information about the alternator. Okay, now we will do the problem. What the question it is given? First question is given as what is the speed. Okay, so what is the speed of the conductor is given. I am keeping like this only, this number of conductors. Okay, let us do the first problem. That is what is the speed he is asking. Speed will be, so we are already know synchronous speed is equal to 120 f by p. The formula for the synchronous speed is 120 f by p. 120 into frequency is 50 hertz and number of poles are 20 here. So what you are going to get, that is 60. So how much it is, 300 rpm. It is rotating at 300 rpm. Second question, what is second question? Generated EMF per phase. EMF per phase, we are already given the formula. That is only formula you are going to get the problems is EMF per phase. That is E RMS you can write, or EMF RMS per phase we can write it as 2.22 into F into phi into, okay, and Z. Okay, so you can multiply, that is 2.22 into frequency is 50 and 0.025 webers, and it is 180 into 8. 180 into 8, that is the formula of induced EMF. So if you multiply, what you are going to get, final answer is, so the answer I am writing directly here, 3996 volts you are going to get. That is the EMF induced per phase. Next, third question, what is third question? It is asked line EMF. So line EMF here, so the line EMF will be, because it is a star connected, that's why I have written here, because the stator is a star connected, that's why always we are already know, in case of star connection, line voltage is equals to √3 times of phase voltage. Line voltage is equals to √3 times of phase voltage. That's why we have to multiply, that is √3 into 3996 volts. 3996 volts, how much it is becoming? 6921 volts. 6921.2 volts. That is the your answer. Very simple. So always you are going to get the problem based on only this formula only, that is EMF. What is the EMF generated in the alternator? Based on that only you are going to get all problems. Let us see the next problem. Let us see the next problem. See, let us read the question paper. Read the question. The stator of a 3-phase 8-pole 750 rpm alternator has, okay, 750 rpm alternator has 72 slots. Okay, 72 slots, each of which contains 10 conductors. Calculate the RMS value of the EMF per phase if the flux per pole is 0.1 webers sinusoidally distributed. So assume full pitch coils and winding distribution factor of 0.96. Let us see this question, how to do the answer. The stator, okay, stator of 3-phase alternator, okay, number of poles are given is 8. Next, so it is rotating at how much speed? That is 750 rpm. It is rotating at 750 rpm. And alternator has how many number of slots? That is 72 number of slots, and each contain 10. That means we can write it 720 number of conductors are there in case of the alternator. Next, calculate the RMS value if the flux per pole. So the flux per pole it is given as 0.1 webers. Next, sinusoidally distributed, assume full pitch. So full pitch means Kp value will become 1 and the distribution factor value it is given as 0.96. Now he is asking what is the ERMS per phase. Okay, so ERMS per phase formula we are already know what is the formula, that is 2.22 into Kp Kd F phi into Z. Okay, that's all. So you can multiply 2.22 into what is the Kp value, it is full pitched coil, and Kd value is 0.96 and frequency is 50 Hz, and phi value it is given as 0.1 and Z value it is 720. So final answer you are going to get, what is the answer you are going to get, it is 3000. So see the answer here you are going to get 7672.32 volts. That is the answer here. Okay, so that is the question and answer. Okay, see the next problem. A 3-phase, okay, let us see the question. A 3-phase 6-pole star connected alternator revolves at 1000 rpm. The stator has 90 slots and 8 conductors per slot. The flux per pole is 0.05 Weber's. Calculate the voltage generated by the machine if the winding factor is 0.96. Let us take this question. Okay, a 3-phase, okay, 3-phase pole, it is number of poles here is given as 6. Next, it is a star connected. The alternator is, that is stator is star connected alternator. Next, revolves at 1000 rpm. It is rotating, that is synchronous speed it is given as 1000 rpm. Next, the stator has 90 slots, okay, 90 slots into each slot is consisting of 8 conductors. That means 90 into 80, you are going to get the total number of conductors, that means 720 number of conductors. The flux per pole 0.05 Weber's. Next, calculate the voltage generated by the machine if the winding factor. So not given, Kp is not given, you assume it as full pitch, and Kd is given as, that is a winding factor or distribution factor, that is 0.96, because whenever Kp is equals to 1, the Kd will become Kw also. Now what is the flux, he is asking what is the EMF. So first for EMF per phase, so RMS value, if you see 2.22 Kp Kd, okay, phi F Z, okay, all are there except this frequency. Let us calculate the frequency first. So you already know synchronous speed value, it is 120 F by P. So what is the F from this? So you are going to get Ns into P by 120. So multiply this and you are going to get, so Ns value it is given as 1000 rpm, the number of poles are 6 and the here it is 120. So you are going to get, so 50 Hz is the frequency you are going to get, that is the 50 Hz frequency. So now you got the frequency, so everything are there in the equation. Let us calculate the answer. 2.22 into Kp value is 1, Kd value is how much, it is 0.96 and frequency flux is 0.05 and number of conductors are 720 and frequency is 50 Hz. What is the answer you are going to get? That is 3836.16 volts. That is the answer. Only twist is asking is only this frequency you have to calculate. That is, he will give the speed. Whenever he give the speed, you have to calculate the frequency. See the next problem. Let us see the problem here. A 6-pole 3-phase star connected alternator has an armature with 90 slots and 12 conductors per each slot. If revolves at 1000 rpm, the flux per pole is 0.05 Weber's. Phase EMF and line EMF, assuming the winding factor is 0.97. Okay, so how to solve the, see the same model question, how to solve here, you see 6-pole, okay, number of poles are given as how much, 6-pole, and 3-phase, okay, it is a 3-phase alternator, 3-phase alternator. So let us say it is 3-phase alternator having number of conductors. Let us write the number of conductors are, it is 90 slots, each slot is consisting of 12 conductors per each slot. So how much you are going to get? 12 lines are 1080 number of conductors you are having. It is rotating at synchronous speed, that is rotating at 1000 rpm. Next, flux per pole is 0.05 Weber's. Next, so that is the question it is given, that is the data it is given. Now Let us calculate phase EMF. So for calculation of phase EMF, because he is given the speed, first we have to calculate the frequency. As we have seen in the previous problem, you can see the frequency, that is ns into p, that is 1000 into number of poles are 6 divided by 120. The same we are going to get, that is the 50 hertz frequency. Let us calculate the phase EMF. Phase EMF is equals to 2.22 into, so and winding factor it is given as the KD is equals to 0.97. So 0.97 into Kp, it is means 1 we are taking. If it is not given, you consider it as full pitch winding. Okay, next frequency is 50 hertz and flux per pole is 0.05 webers it is given. Next number of conductors are 1080, that is the EMF per phase. So how much answer you are going to get? That is 5814.18 volts, that is your answer. Next line EMF is also asking. Line EMF means, because it is a, so here you can see it is a star connected alternator. So here you can see star connected. So you are going to get, that is the line voltage, that is the line EMF will be √3 times of the phase value, √3 times of. So you multiply 5814.18 into √3. So final answer you are going to get it as 10,070.15 volts. That is the how much of EMF will be induced in the lines. Okay, see the next problem. This is the last problem we are going to see. A 12 pole 500 rpm star connected alternator has 48 slots with 15 conductors per each slot. The flux per pole is 0.02 webers. The winding factor is 0.97 and pitch factor is 0.98. So calculate the phase EMF and line EMF. The same model it is also asked. Okay, so 12 pole, let us write the number of poles are 12. Okay, and 500, that is rotating at how much speed? That is 500 rpm. Next it is connected with star. Okay, star connected alternator. Next having 48 slots. Okay, and number of conductors per each slot is 15. Okay, I am keeping like that only instead of time wasting. Next flux per pole is 0.02 webers. Next the winding factor is, that is KD is given as 0.97. Next Kp is given as 0.98. Calculate the phase EMF. Okay, so for this everything is given, speed is given. Now first we have to calculate the frequency, ns into p divided by 120. So ns is equals to 500, the number of poles are 12 and it is 120. So 10 times you are going to get 50 hertz is the frequency of an alternator. Now you got the frequency. Now we can calculate the ERMS per phase, that is the EMF induced per phase, that is 2.22 into Kp value is given as 0.98 and KD value is given as 0.97 into frequency you got it as 50 and phi value it is given as 0.02 and finally we have the conductors, that is 48 into 15. So if you multiply everything you are going to get it as 1519.43 volts, that is the EMF per phase. And he is asking the line. So EMF per line means, because it is a star connected alternator, so what we will do, we will multiply with √3 times. So you have to multiply with √3 into E phase. So √3 into 1519.43, that is final answer you are going to get it as 2631.65 volts. Okay, that is the solution. That's all in this video. Okay, if you have any queries you can comment in the comment box. So if you are like this video, please like, share and subscribe the channel. Share it to your friends, which is very useful for your preparation of external exam. Thank you very much.